Hey, class. All right, number 56. Let me give this one a try. I got a question about it, and I see why. It's got two things put together. It has, of course, our projectile motion, so let's run through that again. But it also has a relative velocities, an addition of velocities, and I can see why that might have given you little troubles because in fact, I just got a question on number 66 also, and I think it's for the same reason. I really didn't explicitly mention adding velocities together. What I did mention is how to add vectors together. And so when I was lecturing it in class, I was talking about little hikes or movements in positions. And somebody wisely asked a question that said, well, what about for velocities, or what about forces, or what about accelerations? And I was glad they asked that because it's exactly the same, and that's what I want to emphasize. But let's start with the first half of it. Let's just start with trying to find the speed, and what I would say is speed relative to the ground. Because listen to this. It says a football quarterback is moving straight backwards at a speed of 2 meters per second when he throws a pass to a player that is 18 meters straight down field. All right. So taking the position of the launching of the football as the origin. And let me just take a moment to emphasize that's extremely important where we choose the origin, because I think another just as valid origin is somebody would pick the ground. And so in green, let me draw the ground. And if you wanted to pick here, that's fine. However, you would have some initial height to the launching of the football, and we're not told what that is. So that just adds an unknown in here. However, it's deleted off because, watch, let's read the rest of it. Let's see. Throws a pass to a player who is 18 meters straight downfield. The ball is thrown at an angle of 25 degrees. Okay, so I'll put a little arrowhead here and put a 25 degrees. 25 degrees relative to the ground, and is caught at the same height it is released. So the football does something like this, and it's caught right here. So with that in mind, you can see that if you pick the origin as the ground, you would say it landed at the same unknown height. And they'll end up canceling off on your equations. For me, I'm going to put the origin where the football is launched. So I'm going to say that the initial, and so maybe I'll just make my two columns like I keep encouraging you. Make one column for X and one column for Y. And so the initial position on the X-axis is 0, and the initial position on the Y-axis is also 0, at least in my system. Like I said, yours you would have some unknown, but the same unknown over here, and they end up canceling off as you do the work. So you could do the origin anywhere you want, but just want to emphasize, make a conscious decision at the very beginning where you're going to put your origin. So I'm putting it at the launch point of the football. So that's why it starts at 0. I'll even say then it lands at 0 in the vertical. Now, in the X direction, I think they want us, let me read it carefully, to put the 18 meters, because they said he throws a pass to a football player, or to a player, who is 18 meters straight downfield. Unless that person, the receiver, is standing still, it begs the question, do they mean 18 meters when he throws the ball or 18 meters from him when he catches the ball? And since they don't say anything about that, I'm going to have to take this that they mean 18 when he catches the ball, whether And maybe he was at 18 when he threw the ball, so that player was, wide open and just stood there, and no defender was around. Anyways, the problem could be stated better, but I think that's what they mean. It goes 18 meters in the horizontal direction, and it goes up a little bit, but comes back down and lands at the same height or is caught at the same height that it is thrown. Okay. It says here, what is the initial velocity of the ball? And then very importantly, they say relative to the quarterback. So the ultimate question is relative to the quarterback. But let's measure everything relative to the ground. So even though the quarterback is moving backwards, so we'll talk more about that in the second half of this problem, let's just do this as a regular projectile problem. And what we're going to do is measure the speed relative to the ground. And so there is some initial speed, v naught, and I'll call v naught x, equaling v naught's cosine of 25 degrees, and v naught y equal to v naught sine of 25 degrees. And I think you guys are getting pretty good at this, but maybe it's worth repeating at least one more time. If you look, and maybe I'll do in red here, the throwing of the football, instead of thinking of it as one speed at an angle, I'm going to do what's equivalent to that, and that's two speeds, a speed in the x direction and a speed in the y direction. So that cosine of the angle, 25 degrees, would be the speed in the x direction divided by the total speed. It would be adjacent over hypotenuse. And the sine of 25 would be the speed in the y direction over the initial speed. So that's how I got this statement. What are the initial speeds in the x and y direction? Now, I suppose it's worth mentioning again what is the acceleration of the football. And, of course, it's a projectile, so it's 0 in the x direction and negative 9.8 in the y direction. Okay. And, of course, we're trying to find this. So, writing down the equation that has to do with position and has nothing to do with final velocity, which is kinematics equation number 2. Let me write that down for both x and y. And then apply it to this circumstance. So I'm going to say x equals, okay, so in this case, the football is starting at position 0. Its initial velocity is a v naught cosine 25 degrees, and its acceleration in the x direction is 0, which simplifies then, sorry, I forgot my t here, to v naught cosine 25t, and maybe taking one more step, since cosine of 25 is just a number, let me get a number to work with, 0.906 v naught t. And this kind of reminds me of the video solution that I did right before this. Forget the number. But they had given us all the same information. It was a soccer player. And in that case, I think the kick was 30 meters downfield. Anyways, they give us, and I'll just put a little circle around this, enough information to know everything except for initial velocity and time. So, actually, why don't I just do one more step? Why don't I take the 18 and divide it by the 0.906 and call that a 19.86. So that's the one I should put a circle around. Okay, so working with the x motion here, I get what is the equation of motion for the x. And there's two unknowns. So by itself, there's not much I can do. But I will need a second equation to have a system of equations. And so hopefully I can do the same thing in the y. All right, so coming over to here, I can put the final position as 0, the initial position as 0, the initial velocity in the y direction, as we said, would be v naught sine of 25 degrees times t. And the acceleration in the y direction is this negative 9.8. So I'll put the negative, and then I'll even take this half of 9.8 and get 4.9 t squared. Okay. And then, since it equals 0, I can factor out a t, and then I'll even get a number for the sine of 25, 423. So 0.423 v naught minus 4.9 t. Now, what's nice about this one is it's not quite a quadratic equation. It doesn't have a constant term. And because it factors, it's a little bit easier than doing the quadratic formula. Although, you could just do the quadratic formula and set c equal to 0, and so that'll work. But that's more work than needs to be done, because when something can factor, then you know either the first factor equals 0, or the second factor equals 0. Both of those would be a solution to the time when the football is at a height of 0. And that makes sense. Time of 0, this one, would correspond to when the football is at a height of 0. Yeah, that's when the quarterback has it. The quarterback has it, and is time equals to 0, it does have a height of 0. Again, putting the origin at where the football is launched. So, of course, this is a solution, not a surprise. I'm going to cross it out, though. It's not the one I'm interested in. The one I'm interested in is the other moment in time right here where the football is also at a height of 0. That's where it's caught by the receiver 18 meters downfield. Okay, so knowing that, I could then start to do my math. And, of course, then maybe solve this one for t and put it into here, or the other way around, solve this for t and put it into here. Actually, maybe I'll do that, because that's how I did the soccer one. I solved the x for t and put it into here. Of course, then I did it that way because we really had a constant and a quadratic, and we couldn't factor it, and so it was easier to sub this way than to sub that way. This time it's about equal. But I'll just go ahead and write this as 19.86 over v naught. And then put that over here to this side of the equation. All right, so 0.423 v naught equals 4.9, and then the time would be 19.86 over v naught. And then if I cross multiply, this v naught downstairs over there becomes v naught squared. And my number over here would be the 4.9 times this 19.86. And then let me also then bring this to the other side. So divide by 0.423. And so this is 230.1. And so getting to the first half of the problem, I get 15.2 meters per second for the initial velocity. And then I want to emphasize, this is the initial velocity relative to the ground. That's not quite what they ask. They're asking the initial velocity relative to the quarterback. So really they're saying from the quarterback's perspective, because they've got this backward motion, so quarterback's moving backwards, and they're going to have to throw it a little faster than this in order to make that 18 meters. This is the appropriate speed relative to the ground. But because there's a backward motion, this quarterback, you need to throw it a little faster than that. Okay, and that's the second half of this problem. So this is just the projectile motion here. But let's talk now about adding vectors again. So the big example I gave you in lecture is I had some vector at a small angle. I think it was 20 degrees. And then I had another vector. In fact, I think that was 11 distance. I think that was 7. And I think this angle was 70 degrees. Not real sure on those numbers. But I do know that what I said is in order to figure out what this is equivalent to, what the result is, which we often draw in red and put an R, is we had to add these two together. And what I said is to get the result in X, you had to take this first vector A and find its X component, and the second vector, call it B, and get its X component, and you had to put X's with X's, and then you had to put Y's with Y's. Oops. Yeah, B, Y. And so there was a little bit of work, but this was the resultant. And what I'm trying to say then is this speed relative to the ground really is the resultant speed. What I need to do then is take what is the speed of the quarterback relative to the ground, then plus the speed of the ball relative to the quarterback, and then I can get the speed of the ball relative to the ground. So this is the result. So in my problem, I guess it would look something like this. Now I would say I'm going to take the first vector, and that's the speed of the quarterback. And so we know the quarterback is running backwards. Let's see, how did it phrase here? The quarterback is moving straight backwards at a speed of 2 meters per second. So if you call this vector A, you might say then that the X component is a -2 and the Y component is 0. All right, so that's my first vector. Now, the second vector, vector B, is of course going to have an X component and a Y component. And perhaps it would look something like this. Okay. That would be what we're looking for. Let me call it V. Oh, how about just kind of a sub Q? Because it's the, well, I should be maybe, it's the speed of the ball relative to the quarterback. So maybe I'll take advantage of both of those. I'll put Q for quarterback and B for ball. So it's the speed of the ball, but relative to the quarterback. You see, and what I have found is this right here. The result. The result of both of those motions, the quarterback going forward and then the quarterback heaving it from their perspective and getting some result that allows the ball, and that's what this picture is, to fly the 18 meters, come down to that same height so that the receiver gets it. So in this case, I know the resultant and one vector, but not the second vector. So it's a little different than what I did in class. In class, I gave you the two pieces that add up and looked for the resultant. Here, I give you, or this problem gives you, one of the vectors, and you're looking for the other vector that add up to the resultant. And you got to get the resultant by doing this projectile motion. Okay, so I know that this result is 15.2 at an angle of 25 degrees. In fact, why don't I just say then, and I'll put right here, what is the resultant in the X and the resultant in the Y? And that's what we had here, right? This is the initial velocity times cosine of 25 is the resultant in the x, and this is the resultant in the y. So grabbing my calculator and going 15.2 times the cosine of 25, the resultant in the x direction should be about a 13.8 meters per second. And in the y direction, it should be 15.2 times the sine of 25, which is 6.42 meters per second. And so those are my two resultants. Okay, so now I can use the stuff that we talked about in class. And that would be taking the resultant in the x, so 13.8 right there, and then the -2, and then the unknown x, well, that is the velocity right there, velocity of the ball from the quarterback in the x direction. And moving this to the other side would give me 15.8. And hopefully conceptually that just kind of makes sense. In other words, we needed, for this ball to make the correct distance to the receiver, 13.8 in the horizontal direction. But of course, the quarterback needs to throw it 2 greater than that because the quarterback is in the process of moving backwards at 2. So the quarterback, relative to his thinking, is to throw it at 15.8 meters per second. So that relative to the ground, it's 13.8, and that would be the correct horizontal speed in order to get to the appropriate place. All right. Now, the y direction's a little boring because the resulting y, 6.42, if we put it into this equation, would be then the 0 from the motion of the quarterback, and then this b is what we're looking for. How fast does the quarterback have to throw the ball relative to the quarterback? And so the vertical speed that the quarterback throws it relative to the quarterback is the same as relative to the ground. So the upward motion is the same. And that kind of makes sense because the quarterback isn't moving up and down. So there's no adjustment in speed that needs to be made. If the quarterback wants to throw the ball with a speed of 6.42 in the vertical, even if they're moving backwards, this is how much vertical speed they give it because there's no effect on the vertical. The motion of the quarterback is backwards, and so he has to compensate for that speed in the x direction, but not in the y direction. All right. So now we can finally answer this question, and so maybe I should point out this would be the velocity of the ball from the quarterback or relative to the quarterback in the y direction. And they ask for that initial speed. So from the quarterback's perspective, quarterback is throwing it with this much horizontal and this much vertical. So if I had a grid, and I said, okay, I'm going to give it this horizontal speed of 15.8 and a vertical speed of 6.42, the result of that is what I would be looking for. And so this right here is the velocity of the ball from the quarterback. And maybe I'll just say naught, the total velocity. And then there would be even some angle. And I think I need to do both since they say velocity. So I need a magnitude and a direction. All right, so to get the magnitude, I'm just going to do the Pythagorean theorem. 15.8 squared plus 6.42 squared would then be the velocity of the ball from the quarterback initially squared. And so now I have what they're looking for in the second half, and what's the velocity of the ball from the quarterback. So 15.8 squared plus 6.42 squared, square root of all of that, and I get 17, I'll round it to a 1, 17.1 meters per second, okay? In fact, I kind of like the 17.05. That might be a violation of the significant figures. But it has me coming back to a mistake that's easy to make. Somebody could just say, well, just take the 15.2 and subtract 2 because the quarterback's moving back 2. But there's the problem. It is not moving in the same direction as the ball speed is relative to the ground. So you don't subtract 2 from the total speed. You subtract 2 from the horizontal speed only, and then go back and use Pythagorean theorem. Now, with our numbers and our angle, that's going to be really close to 2, but it doesn't necessarily have to come out that way. And so ours is, as you can see, not quite 2. And so if all I did was subtract 2, I'd be making a mistake. Because I'm not taking into account for direction. All right. Hope that helped. Bye now.